What do we mean when functional programmers talk about immutability? Do things really have to never change? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So, immutability is one of those things that comes up a lot when people are talking about functional programming. And I want to talk about some of the more practical aspects of it, not just the theoretical. So the theoretical says that an immutable value cannot be changed. Now in practice, there are several ways that you can enforce that. And sometimes you don't have immutability in your language, and so you have to do something else. And it's really just how you interpret that cannot. So one thing is the language could enforce it, or the particular object, the data itself, might not have any methods on it that allow it to be mutated. That is one way of enforcing this discipline, this rule that things shouldn't be mutated. They can't be mutated. But another way is you could just have let's call it a developer policy that says we don't mutate. Okay? So maybe the object is mutable. You could, but you don't. Right? So you just apply the rule, but you have no help from the language or your compiler or anything. So that's the practice of it. So if you're in JavaScript and you have some mutable thing like a JavaScript object, or you have a JavaScript array, those are mutable, but you could practice immutability by, in practice, never changing them, even though you could. So given that you could change them, there are, and you sort of need to make modified versions of these things. Even if you aren't changing the thing, you want to be able to add a new element to your object or to your array. And so how do you do this? Well, there's actually 2.5 disciplines for doing this. The first one is called Copyonwrite. So this means whenever you need to make a modification to an object, you don't know who else has a pointer to that object, so you don't want to change that, because then you're breaking your rule of immutability. So you make a copy and then change the copy. Now, you're changing it, right? You're using mutation, but no one has a reference to it yet, so no one has seen it but you. And then once you give it out, now, boom, it's the immutability rule is now enforced, and no one else can change it. You're not going to change it, and you're saying no one else can change it. So if you get, the rule has to be applied like unilaterally. So once you give away a pointer to it, you cannot change it. And if you get something that you didn't create yourself, meaning you know exactly the code path that it went through to get to you, you can't change it either. Okay? Because someone else might already have it. So those are the two rules. If you get something, you can't change it, and if you need to make a change, you have to make a copy and then change that copy that you control. So that's called Copyonwrite. There's another one called Copyonread. So this one is, if you get something from someone and you're not sure if this library, this API that you're using believes the same things you do about immutability, if it's even implemented correctly, if they enforce the rule properly, So you don't believe that this system is immutable. So what do? You make your own copy of the thing. And that means that the library can modify the one that it gave you all it wants. What's important is that the one that you keep is under your control. And you're only going to pass it to things that you believe will be immutable. So let's talk about the rules of this. If you get something from an untrusted source, meaning you don't trust that it enforces immutability, you make a copy and you throw away the old one. You throw away the one they gave you. Okay, you just immediately make a copy, and that's the one you keep. And then if you're going to give your ostensibly mutable thing to something else, you don't trust that it's going to maintain your discipline of immutability. You have to make a copy before and give them the copy. And you can say, look, you can do whatever you want with this. I've got the original copy, and you can tear that up, you can write all over it. I've got the original. Okay. So those are the two main disciplines, and you're going to have to, if you're living in a language or a runtime that allows for mutability of your main objects, you're going to have to do those kinds of things, those two disciplines. One is defensive and one is more offensive, right? Now, you're going to probably have to do both, depending on the situation. If you're dealing with untrusted code, you want to do Copyonread, and if you're dealing with your own objects, that you maintain, you're going to do Copyonwrite. Because within your own code, you trust that you're being immutable, that you're enforcing your rule of immutability, and so you don't have to copy every time you read. You only have to copy when you need it to modify it. Okay. The half one, I said there were 2.5. The other one is called append only. Now this is only a half because it doesn't really apply in most cases. It's just not applicable. You can't use it. But there are certain data structures that let you apply an append-only discipline, which means you don't modify the thing, you only add to the thing in a way that doesn't modify the original. So just as an example, if you have a stack, and let's say you only push, you never pop, right? So it's append only, it's push only in this case. If you have this stack, things can push without modifying anything underneath the top of the stack, right? And so you can share this thing around because this stack is only growing, right? So none of the old stuff is being modified. So it's kind of immutable in that way. Now if it's an immutable implementation of a stack, meaning every time you push, you're actually creating a new a copy, then that's even better. But I'm just talking about a regular mutable stack where you're adding stuff. All you can do is add. You can't remove and you can't modify anything that's on there already. That has a kind of immutability to it, right? That it's only growing in a known way without modifying the old stuff. So in theory, if you had a pointer to the stack up to this height, you know that stuff is only getting added on top, so I can still read this safely and be sure it's never going to change, right? But of course, this is just another discipline, this append only. Does your language help you do this? Does it have a pop method? Does your stack have a pop method that someone might accidentally call that doesn't realize that it shouldn't do that in your system? That's how much the language affords doing immutability. Okay, now some languages like Clojure enforce these automatically. It does not enforce Copyonread. It doesn't need to because the objects are immutable. There are no methods on them that can change the state inside the objects, right? They are immutable. But it does do a Copyonwrite. So if you want to add a key value to a hash map, it actually makes a new hash map with all the existing key values plus the new one that you're adding. Okay? Now, it does that very efficiently because it's going to share most of what already exists with the old copy. Okay, so you can have both copies in memory, and even if there's if there's 1,000 keys and values in those hash maps, in that hash map, and you add a new one, in theory you have two hash maps with 1,000 copies and 1,001 copy. 1,000 key values and 1,001 key values. But most of it is the same, is shared between the two. So only a very small amount of memory has to be duplicated to have both. And that's called persistent data structures. What persists is the structure of the pre-existing hash map when you make a copy to a new hash map. All right, so that's immutability. I hope that explains what it is and how it's done. I didn't really explain very much about why, but that could be a topic for another of these episodes. Thank you. See you later.